My name is Michelle Walden, and this is my Unit 4 Case Connections presentation. There we go. All right, I'm just going to open this up. Go. All right, so I like to list the question first. It makes it a little bit easier to follow along. So I did case 2 and case 3. Case 2 says that a 40-year-old infant, patient A, is being followed in your clinic. Her birth weight was 5.9 pounds, and the pregnancy and birth were normal. Results from newborn screening demonstrated a phenylalanine level of 6.6 milligrams per deciliter, the normal range being 1 to 2 milligrams per deciliter. A presumptive diagnosis of Phenylketonuria was made, and additional samples were obtained for further analysis. The parents deny a family history of PKU. Now, this case is separated into several questions, so I'm going to give you the first one, and we'll go from there. The first question is, as a consequence of this presentation, which amino acid may become essential? Now, first I'm going to kind of explain what phenylketonuria is, and I'm going to refer to it as PKU, just to make our lives a little easier. So it is a disorder of amino acid metabolism in which the enzyme phenylalanine hydroxylase is deficient. This causes high levels of phenylalanine to build up in the blood. This is just kind of a basic picture to kind of show the breakdown of it. Although this disorder can be corrected with a phenylalanine-restricted diet, it's usually discovered at very early stages of development in which a proper diet has not yet been established. Here's a good picture of phenol-free foods, which we'll refer to later. If left untreated, phenylketonuria can lead to hindered brain development and epilepsy, microcephaly, and other neurological symptoms, just to start us off. As discussed in lecture, when phenylalanine metabolism is impaired, tyrosine becomes our conditional essential amino acid and must be obtained from an out-of-body source. This is just kind of a picture giving you an idea of how that works. Phenylalanine dietary restriction therapy was initiated at 14 days of age with good response of plasma phenylalanine levels that dropped to within the normal range, 1.65 milligrams per deciliter. So what are the potential causes of the presentation of phenylketonuria? So phenylketonuria is an autosomal recessive genetic disorder, which I've kind of given you a picture of here to break it down, which means it is inherited by two carrier parents that don't necessarily show symptoms themselves. Although it is mentioned in this case that the family has no history of PKU, but it is possible that patient A has mild PKU, which means they can tolerate higher amounts of phenylalanine than those with classical PKU, and are usually diagnosed with phenylalanine blood levels between 2 and 6, which is consistent here in this case. Those with mild PKU may be more likely to have a less noticeable genetic history of PKU, which I kind of demonstrated here in the percentage of patients showing the phenotype, which is the physical presentation of the gene. In first the classical and then the mild are those first two bars. The other two are different conditions. It has been suggested that the cause of the disturbed brain development in PKU patients is due to the competition among the large neutral amino acids, or LNAAs, to cross the blood-brain barrier. When phenylalanine, one of these LNAAs, is in excess, it will most likely win this competition. And this picture kind of gives you an idea of what that would look like. A study posted in the Journal of Clinical Investigation tested this theory by introducing the other competing LNAAs into the blood of the patients with PKU. This is just a quick link if you wanted to hop over to that study and take a peek, and I drew this table directly from that article. The amino acids used in the study, some of which we have discussed in lecture, include valine, leucine, isoleucine, methionine, histidine, tyrosine, and tryptophan. So those are listed here on the chart. They also list lysine, but didn't really affect the study, so I didn't feel like I had to mention it. Okay, the results of the study showed that the supplemented LNAs did not completely decrease the levels of phenylalanine, but did stop them from rising significantly. Based on the data provided, the amino acid valine appeared to cross the blood-brain barrier at the highest concentration. So you'll see on these graphs that there's two lines. The dark line is the amino acid that has been added and is prominent, and then the comparison to the dotted line, which is the levels of phenylalanine. So you'll see valine here in chart B is definitely winning the fight there. Okay, another infant, patient B, is also being evaluated for suspected PKU. BH4 loading tests are performed on both patients, and the results are presented below. Here's the chart that they gave us. How would you summarize the results of this test for patient A and patient B? So in order to do that, I'm going to explain what a BH4 loading test kind of does exactly. A BH4 loading test has shown promise in treating phenylketonuria by lowering phenylalanine concentration levels in the blood. As mentioned in lecture, BH4 is a cofactor in amino acid metabolism used by the phenylalanine hydroxylase enzyme to convert phenylalanine to tyrosine. So it's pretty important. Just a simple picture here to kind of show that. Okay. Another study performed by these two people whose names I can't pronounce, titled Assessment of Tetrahydrobiopterin, which I also can't pronounce, Responsiveness in Phenylketonuria. It basically displays the outcome of a BH4 loading test for us. In the results of the test, it is observed that the patients with PKU experienced a decrease in phenylalanine levels after 4 and 8 hours. Those with mild PKU benefited more from the test than those with classical PKU. So you'll notice on the graph, there is a 24-hour test, but it wasn't as relevant towards the study. So the 8 hours test is the graph that you want to really pay attention to here. Based off of this information, the BH4 loading test performed on our patient A and patient B in this case can be decrypted. The graph suggests that patient A most likely did not have symptoms of PKU at the time of the test due to the rise in the phenylalanine levels shown in the graph. In contrast, patient B's phenylalanine levels decreased significantly. Therefore, patient B most likely has classical or mild PKU without the proper dietary restrictions. All right, the next case that I did was a 47-year-old man presents with severe pain in his right great toe. He is unable to bear weight on his right foot and therefore there was no trauma, he reports the pain started last night and continued to increase in severity. Based on his physical exam and laboratory findings, he's diagnosed with gout. Gout can be caused by several different mechanisms, and blood samples are drawn and urinalysis is performed. The results from this individual are listed below. So this shows you the comparison of the plasma urate and urinary uric acid in the patient and what would be normal. What is the best explanation for the presentation of gout in this individual? And please explain why the other choices are not consistent with the data, or what additional information you may need to decide the root cause. So there's 3 options there: overproduction of purines, decreased salvage of purines, decreased urinary excretion of uric acid. And that's just the first part of this question. I will separate it into the second part later on, just to make it easier. Okay, so to explain gout a little bit, it is the clinical presentation of hyperuricemia, which is when the body has an excess of uric acid. Uric acid is not completely soluble, so during metabolism it leaves behind a precipitate in the form of monosodium urate crystals. When a large amount of these crystals builds up in one location, they cause the inflammatory response referred to as gout, which I have pictured here. Very simple picture. So in this case, the lab tests exposed the suspected diagnosis of hyperuricemia, with the uric acid levels excreted in the urine being very low and the plasma urate in the blood being very high. So I kind of have a table here, how you would classify hyperuricemia, and it kind of lays out a little bit more detail of what I'm saying. It's not clear as to what the biochemical reason for the presentation of gout is with just the blood tests and the urine analysis, because it is possible to have hyperuricemia and not have gout. Okay. The decreased urinary excretion of uric acid would explain the low urinary uric acid in combination with the fact that the patient's episode of gout was idiopathic with a lack of neurological symptoms. Idiopathic meaning just it was brought on quickly and suddenly. The other 2 possible causes, we talked about overproduction of purines and decreased salvage of purines, would have neurological symptoms, and physical symptoms would likely appear gradually over time, not idiopathically. So an example of one of those would be the Leishman syndrome, which it's a good picture here describing that, but yeah, there are neurological symptoms along with gout presentation. Aspiration of the inflamed area and analysis of its synovial fluid would be the most likely next step in confirming the diagnosis. So I kind of brought up a picture here to show, in case you didn't know what an aspiration was. Also, radiographs and ultrasonography would aid in the diagnosing of gout. Also, a detailed family history would be helpful because hyperuricemia can be the precursor to future health problems, some of which are genetic, which I've shown you a picture here that has the different genes that are similar for gout and obesity and diabetes, and very similar genes there. So it's very important to have a good family history when diagnosing. Ingestion of food high in purines could also cause hyperuricemia, so a detailed food log would be useful in diagnosing. So here's just a fun picture to show you that. After further discussion with the patient, he tells you that he recently switched from diet soda to regular soda because he read that the fake sugar diet soda was bad for him. He tells you he drinks between 4 and 5 liters of soda a day. The primary sugar in most soda is fructose or high fructose corn syrup. So the question is, what is the potential impact of this dietary modification on the presentation of gout? So in order to answer that, I did find another study, and this study is mentioned in the article, The Epidemiology of Uric Acid and Fructose. So an increase in fructose in a person's diet increases serum uric acid production by increasing ATP degradation to AMP and therefore accelerating purine synthesis. And here's a quick link if you wanted to refer back to that. But here is a graph that I drew from that study. So you can kind of see how the high fructose corn syrup consumption rises at the same time the prevalence of gout rises in comparison. And this is an older study, but it is still relevant to today. And that is the end of my presentation. I hope everyone is being safe and well, and it's been a pleasure taking this class with you.